Good days to Dr. Azri. My name is Q Agustinus. Today I will present the cost classification and behavior for Innotech Manufacturing Ltd's HVAC expansion project. Cost classification is important because it helps management understand where is the money being spent and how costs change as production increases. In this project, costs are classified into direct materials, direct labor, manufacturing overhead, and administrative expenses. Direct materials include steel, sheet, copper, tubing, refrigerant components, and electrical wiring that are used directly in production HVAC units. Direct labor consists of wage paid to workers involved in assembly, welding, and testing processes. Manufacturing overhead includes indirect production costs such as factory rent, utilities, equipment depreciation, and maintenance expenses. In this project, the fixed manufacturing overhead is 150,000 per month. Administrative and selling expenses are estimated at 30,000 per month. Cost behavior can be divided into variable costs, fixed costs, and mixed costs. The variable cost for each SVAC is 1,600. As production increases, total variable costs also increase. Fixed costs remain constant regardless of production volume, while mixed costs contain both fixed and variable elements. Understanding cost behavior allows Innotech to prepare accurate budget, perform break-even analysis, control costs effectively, and make better management decisions.
Moving into our cost analysis, we have selected process costing as the appropriate technique. Why it's suitable is because since our HVAC production involve large volume of standardized units undergoing an identical production step with minimal customization, process costing is the most accurate method. How it works, unlike job order costing, we track costs by department and spread them evenly across all units produced rather than focusing on individual orders. This gives us a reliable average cost per unit. The benefit is by implementing this, we gain critical advantage in making informed pricing decision, creating accurate budget, managing overhead costs, and conducting performance assessment. Alignment with growth. This method perfectly support our growth strategy, which focus on boosting production level through automated robotic welding within a consistent manufacturing environment. To illustrate how this work in practice, let's walk through a sample calculation based on our first month operating budget. From the table, we are forecasting a production volume of 200 HVAC units. Our total variable production cost is 320,000, and we have a monthly manufacturing overhead of 150,000. And when we combine these figures, our total manufacturing cost comes to 470,000. As shown in the formula, we divide the total manufacturing cost by the total production volume. By dividing 470,000 by 20 units, we arrive at an average unit cost of 2,350 ringgit. This clear per unit breakdown allows the management team at Innotech to understand exactly how production volume directly influence our financial baseline.
Moving on to the next critical phase of our operational and financial evaluation for Innotech manufacturing. I will be discussing the section 3.0, budgeting and forecasting, followed by section 4.0, break-even and profit planning. Let's begin by looking at our sixth slide, which outlines our operating, budget, and cash flow forecasts. The operating budget is prepared to estimate our expected revenue, production costs, fixed expenses, and net income based on our forecasted sales volume. This allows the company to control these costs and monitor financial performance throughout the project. To build this budget, we established several key forecasting assumptions. We set the selling price per Hvac unit at 2,500 ringgit with a variable cost of 1,600 ringgit per unit. Furthermore, our monthly fixed manufacturing overhead is projected at 150,000 ringgit alongside monthly administrative and selling expenses of 30,000 ringgit. For our first quarter expansion plan, our forecasted sales volume in the first month is 200 units. We projected a forecasted sales volume growth of 10% per month, meaning we anticipate selling 220 units in month 2 and 242 units in month 3. When we compile these figures, the operating budget shows that Innotech is expected to generate 1,655,000 ringgit in revenue, although the first month is expected to break even with zero net operating income. Profitability improves in the second and third months, resulting in a total first quarter net operating income of 55,800 ringgit. It is also vital to observe our forecasted cash flow statement. In month 1, we experienced a cash outflow for a machine purchase capital outlay of 300,000 ringgit. This causes a net cash flow of negative 300,000 ringgit for the first month. However, as sales receipts come in, our cash position recovers, leaving us with a closing cash balance of 105,800 ringgit. Focusing on section 4.0, break-even and profit planning. Break-even analysis is used to determine the minimum number of Hvac units that Innotech Manufacturing must sell to cover all fixed and variable costs. At the break-even point, the company does not make a profit or loss. To calculate this, we first establish our contribution margin per unit by subtracting our 1,600 ringgit variable cost per unit from our 2,500 ringgit selling price per unit. We calculate a contribution margin at 900 ringgit. Next, we apply our fixed costs of 450,000 ringgit to the formula by dividing 450,000 ringgit fixed costs by the 900 ringgit contribution margin per unit. We determine our break-even sales volume to be exactly 500 units. In short, Innotech must sell 500 Hvac units to break even. The excellent news for our expansion plan is that based on the first quarter operation budget, the forecasted sales volume is 662 units. This is above the break-even point by 162 units, which shows that the expansion plan is expected to be profitable during the first quarter. This brings us to our margin of safety. The margin of safety represents the difference between our forecasted sales units and our break-even units. By subtracting 500 from 662, we find a margin of safety of 162 units. When we calculate it as a percentage, this is roughly 24.47%. This means Innotech's forecasted sales can decrease by about 24.47% before the company reaches the break-even point. Finally, as illustrated in the report's break-even graph, the total revenue line and total cost line intersect at exactly 500 units. At this intersection, both total revenue and total cost equal to 1,250,000 ringgit. Any sales volume above.
Hello everyone, for my part, I will present section 5 and section 6, which are capital investment and project evaluation and inventory and cost control. For capital investment, Innotech Manufacturing Limited plans to purchase a new robotic welding system. The purpose of this investment is to improve the production efficiency and quality of Hvac unit. The initial investment is 300,000 ringgit. The project life is 5 years with annual savings of 90,000 ringgit. The discount rate used for evaluation is 10%. Next is the net present value or NPV. NPV is used to determine whether the project can generate value after considering the time value of money. Based on the calculation, the total present value of cash inflows for 5 years is 341,163. After deducting the initial investment of 300,000 ringgit, the NPV is 41,163 ringgit. Since the NPV is positive, this means the investment is expected to generate additional value for the company. Therefore, based on NPV, the robotic welding system should be accepted. The second evaluation method is internal rate of return or IRR. IRR is the discount rate that makes the NPV equal to zero. From the calculation, the IRR is approximately 15.24%. This is higher than the company's required return of 10%. Therefore, the investment is financially attractive. Both methods support the same decision. The NPV is RM 41,163 and the IRR is 15.24%. So the recommendation is to accept the purchase of the robotic welding equipment. This equipment can increase production efficiency, reduce labor costs, improve welding consistency, reduce defects and rework, and improve profitability. Now, I will move to Section 6, Inventory and Cost Control. As a manufacturer of Hvac units, Innotech has several types of inventory. The first is raw materials such as steel sheets, copper tubing, refrigerant components, electrical wiring, fasteners, and fittings. The second is work in process or WIP. This includes Hvac frames under assembly, units awaiting welding, and components waiting for testing. The third is finished goods, which are completed Hvac units that are ready for sale and delivery. The last one is MRO inventory, which means maintenance, repair, and operating inventory. Examples are welding electrodes, lubricants, safety equipment, spare machines, and cleaning materials. To control inventory and cost, several measures are proposed. First, the just-in-time system can reduce excess inventory by receiving material only when needed. This helps reduce storage costs, obsolete inventory, and WIP accumulation. Second, barcode and RFID tracking can improve inventory accuracy and reduce manual recording errors. Third, ABC analysis can classify inventory based on value and importance. This allows management to focus more on high value and critical items. Fourth, cycle counting can be used instead of only doing annual stock taking. This helps detect stock discrepancies earlier. Finally, lean manufacturing can reduce WIP and waste, improve production flow, lower holding costs, reduce lead time, and improve productivity. In conclusion, the robotic welding system is a good investment because it has a positive NPV and IRR higher than the required return. At the same time, proper inventory and cost control measures such as JIT, barcode, or RFID ABC analysis, cycle counting, and lean manufacturing can help Innotech reduce costs, improve inventory accuracy, and strengthen profitability. That's it all from me. Thank you.
Moving on to the performance measurement and key performance indicators or KPIs. KPIs are measurable indicators used to evaluate whether Innotech Manufacturing Ltd is achieving its operational and financial objective during the HVAC expansion project. For financial performance, two important KPIs are net profit margin and return on investment or ROI. The profit margin is 3.37%, which means the company earns 3.37 ringgit profit for every 100 ringgits of sales revenue generated. The ROI is 13.72%, which is higher than the required return of 10%. This indicates that the investment in robotic welding system is financially beneficial. For operational performance, the projected production output for the first quarter is 662 HVAC units. In addition, the company is expected to achieve a monthly growth rate of 10%, showing that the production capacity is increasing according to the plan. Overall, this result indicates positive financial performance and successful operation expansion. For quality performance, Innotech aims to maintain a defect rate below 2% and a rework percentage below 3%. These targets are important because they help ensure that HVAC units meet customer requirements while reducing additional production costs caused by defect and rework. For inventory performance, the company focus on inventory turnover and inventory accuracy. The inventory turnover ratio is approximately 3 times during the first quarter, indicating that inventory is being used efficiently and converted into sales at a reasonable rate. The company also target an inventory accuracy level above 88%. This can be achieved through the use of barcode system, RFID technology, and regular inventory monitoring. By maintaining high product quality and effective inventory management, Innotech can improve operation efficiency and customer satisfaction. Lastly, for the project performance KPIs, Unitech uses two important indicators, which is the Cost Performance Index or CPI and the Schedule Performance Index or SPI. The CPI measure efficiency by comparing the earned value of complete work to the actual cost incurred. A CPI greater than or equal to 1 indicates that the project is operating within budget. Similarly, the SPI measure schedule efficiency by comparing complete work with planned progress. And SPI greater or equal to 1 indicates that the project is progressing according to schedule. In addition, the project has a positive net present value of 45,163 and the internal rate of return of 15.25%, which is higher than required return of 10%.
So next, I'm going to talk about the EVM cost control and variance formula. So to monitor our hatchback expansion costs, we implement and value management EVMs instead of relying on lagging accounting data. So we track three real-time variables, which is planned value PV, our 300,000 baseline budget, actual cost AC spend, and earned value EV to represent physical work complete on the factory floor. So by continuously monitoring absolute variance and keeping our efficiency indexes, CPI and SPI strictly at or above or our target threshold of 1.0. So we ensure our robotic welding line goes online exactly on time in week 7 without draining corporation profit. So next, I'm going to talk about real-time cost tracking tool. So to link our on-site engineering operation with corporate financial reporting, we employ a three-tier software framework structure around the project triple constraint. First, we use Microsoft Project to manage our critical path and timeline shift. Second, a centralized live site Excel tracker cell as our daily ledger. So computing raw material transaction cost against our standard costing target. So finally, this live data feed directly into automated Power BI dashboard, so giving sketch holder immediately visual tracking the data at our project efficiency metric, same like our Gantt chart. So next, I'm going to talk about cost-benefit analysis CBA. So moving into section 9.0, we evaluate whether to automate our welding process in-house or outsource it to an external vendor using a 5 years present value framework at a 10% discount rate. So as shown in the sheet, alternative 1, in-house automation require an upward capital outlay of 300,000 but generate massive operational saving, yielding a positive net present benefit of 3,255. So conversely, alternative to outsourcing requires zero initial capital but accumulative vendor fee and quality rework overhead, resulting in a net loss of minus 265,355 ringgit. So last but not least, to validate this decision and the real world validity, we perform unexpected monetary value EMV decision tree analysis, modeling high market demand at 60% probability and low market demand at 40%. This adjusted calculation proved that keeping production in-house yields strong positive EMV, which is 14,697 cents, while outstanding drops to a negative EMV, which is 12,000, due to low demand vendor penalties. Thus, our final strategic recommendation is to pursue the robotic welding equipment to maximize capital value and secure absolute control over quality and logistics. So that's it.